All right, so let's talk about midpoint of a segment next. So a midpoint is a point that divides a segment into two uh, equal segments, or in geometry, we use a word that's a little more comprehensive than equal, that is congruent. So a midpoint divides a segment into two congruent segments. Okay, so the symbol for congruent is the equal sign with the little enya on top, and so what that means is not only are their lengths the same, but all the dimensions are the same, all the characteristics are the same, and so forth. Okay, besides orientation. So like you could have two congruent segments like that are, you know, one like this and the other one like this, and they could still be congruent even though one is vertical and one is horizontal. So apart from orientation, um, all the other aspects of that figure are the same. Okay. Um, all right. So, um, so in this case, we M is the midpoint of AB. So M is the midpoint of AB, right? So it means that not only is it between, not only is it somewhere between A and B, but it actually cuts the segment AB in half, right? Or it divides it into two congruent segments. All right. You might also notice that there's these little tick marks here, right? So those little marks, um, since you have one mark on each line, they mean that those lines are congruent to each other, right? I could also put, um, like this one here could also be congruent. So if I put a mark on this line here, that means it's also congruent to AM and MB, okay? But let's say if I put two marks on here, that means uh, it's congruent to a different line, right? Okay, so if I have like, four segments in a picture like I do here, actually we have five including AB, then these two are congruent to each other, right? And these two are congruent to each other, but they're not. But AM is not congruent to this line X Y, right? For example. Okay, so the number of tick marks correspond with congruent statements. All right, so next let's talk about bisector of a segment. A segment bisector can be a point, a line, ray segment that intersects a segment at its midpoint. Okay, so any of these figures could intersect a segment at its midpoint, right? And so that's said to be a segment bisector. Okay, or it's going to bisect the segment. Bisect would be the verb, right? So in this case, AX equals XB, right? So AX, draw a tick mark there, equals XB, right? So plane M, this plane here, M, intersects AB, RS, or excuse me, not just intersects, but bisects, right? RS, the line RS, right? Here's R and S, so this line here also is a bisector. Segment VW is a bisector. You could also say ray SR is a bisector, right? Those are all bisectors of AB. Okay. All right, so let's see some examples to hopefully kind of solidify your understanding. So number one, BD. So it's asking us to find BD. So remember, that's the length from B to D, right? Or the length between B and D. So what we do is we just find the coordinates, which remember are the real values that are associated with those points, and we just subtract them and find the absolute value, right? So for me, I just do bigger number minus smaller number, and that gets the absolute value. But just to be sure, we'll just put the absolute value that bars there. So 4 minus negative 1 is the same as 4 plus 1, which is 5, right? So BD is 5. You can also count you can say, okay, this is 1, 2, 3, 4, 5, right? So that's another way to find that value. But sometimes you may be given just the coordinates and not the number line, and so it might be easier to use the coordinates, or it might be that they're so far apart that it'd be a lot more time consuming to count than just to subtract. All right, number two, find the length of segment AC. So same process. So let's see, segment AC. So from -3 to 2. So I'm just going to do 2 minus -3. And that's going to be 5, right? So even if I did -3 minus 2, I would have had -5. But remember, always take the absolute value when you're finding length, okay? All right, find the distance between B and E. So, same question, just asking us a different way. So B and E. So we're going from -1 to 6. So I'm going to do 6 minus -1. Take the absolute value of that. So we get 7. All right, so now number 4 is asking us to find the coordinate of the midpoint of segment AE, right? So segment AE from here to here, right? So how would I find the midpoint? So, and there's a couple different ways you could do it. So first you could find the length, cut the length in half, and then figure out what point is that distance away from A or E in between them. So that's probably the kind of the most intuitive or straightforward way to do it. So we'll do it that way. So I'm going to find the length of AE, and I'll show you another way too. So the length of AE is 6 minus -3. So that would be 9, right? Okay, so if I divide that by 2, I get 4.5. So if I go 4.5 units from A towards E, or from E towards A, either way, I'll get the coordinate of the midpoint, right? So I can either do 6 minus 4.5, or I can do -3 plus 4.5, right? Either way, we'll get the same thing. -3 plus 4.5 is 1.5. 6 minus 4.5 is also 1.5, right? So that's just more confirmation that is the midpoint, because it's the same distance away from each of the endpoints. So 1.5 would be our answer. All right, you might have seen the midpoint formula before too. The midpoint formula says if you add the coordinates and divide by 2, you get the midpoint. Okay, and so basically, if we do let me write the formula first. A lot of times you'll see it like this: x1 plus x2 over 2 is the midpoint. And so anyway, in this case, it would be 6 plus -3 over 2, which would be 3 divided by 2, which would be 1.5. All right, so 2 different ways to do the same thing, and either one is fine with me. All right, so next, find the value of x given this situation, right? All right, so here we have a situation where we have A, B, and C that are collinear, and B is between A and C, and so we can use the segment addition postulate, right? We can say that AB plus BC has to equal AC, right? The two parts have to equal the whole, right? So it's intuitive. So basically, x plus x minus 6 equals 18. So x, a funny x, plus x minus 6 equals 18. And then we can solve that, right? So we combine like terms. I'm also going to add 6 to both sides. And so we'll end up with 2x equals 24 divided by 2 to get x totally isolated here. And we end up with x equals 12, right? So remember, be careful to check your directions here. They just asked for the value of x, so we found that. So we're done, but they also might say find the value of BC or find the value of AC. Or, well, in that case, that's given. But find the value of one of the segments, right? All right. So number 6 in the diagram, AC is congruent to CE. Segment AC is congruent to segment CE, and B is the midpoint of segment AC. So here we're given that the length CD is equal to 2, the length AB is equal to 3. So it's asking find BC, AC, and DE, right? So a couple things, since we know that B is the midpoint of AC, so B is the midpoint of AC. So therefore we know that AB is equal to BC, right? So I can put the tick marks there. And so if we're given the length AB is 3, BC has to also be 3, right? Okay, let's plug it. Let's also put in what else we know, which is CD equals 2, right? So I'm going to put a 2 there. Okay, so now they're asking for BC. So from B to C, we just found that that's equal to 3. So BC equals 3. We already figured that out. AC, well, we know segment addition postulate, right? AB plus BC must equal AC, right? So AC is going to be 3 plus 3, which is 6, right? Okay, so this distance here is 6. And it's also asking for DE. So we know that segment AC, going back to this here, I forgot to include that when we were finding stuff earlier. So segment AC is congruent to segment CE, right? So those are congruent to each other. So therefore, if I know AC, which is 6, CE is also going to be 6, right? From here to here. Okay, so if I'm looking for DE, this distance, right? How do you think we can find that? If I know this whole thing is 6, and I know this part is 2, what does this part have to be? And you're right, we subtract, right? The answer is 4. And that's just using the segment addition postulate, right? I know that CD plus DE equals CE, so I'm asking myself 2 plus what equals 6. And so, so another way to answer the question of 2 plus what equals 6 is to subtract 6 minus 2, right? Which is 4. Okay, so the last value that we found for DE is 4.